Hi everybody, in today's video we will be covering how to find the volume of a parallelepiped formed by three vectors. Before we begin any examples, I will quickly run through the formula we will use today. The volume is the absolute value of the vector A dotted with the cross product of vector B and the vector C. This is also known as the triple scalar product. Now, the volume is also equivalent to the absolute value of the determinant of a 3x3 matrix with the vectors A, B, and C in each row. Here is a quick example of how to find the determinant of said matrix. If you'd like to see a more detailed explanation, please comment and subscribe. On to the examples. So, the three vectors we will use to find the volume of a parallelepiped is A, B, and C. As seen by the formula, the volume is the absolute value of the vector A dotted with the cross product of vectors B and C. As discussed before, it is also equivalent to the absolute value of the determinant of a 3x3 matrix with vectors A, B, and C in each row. In order to solve the determinant, we will be using cofactor expansion. Again, if you'd like to see a more detailed video explaining how to do these steps, check out my YouTube channel. Okay, so we now have the 3x3 matrix and we need to find the determinant. So let's start with our cofactor expansion. Let's start off by starting with our first row and we work our way through the columns. So we have 1 and this is equal to 1 times the determinant of the matrix left over. Now we move across the row now. Here we are. And now it's 2. And we move across in a checkerboard pattern for those who remember. Now we go minus 2. And what's left? 0, minus 2, 1, and 3. And now we move across. So it becomes plus 2 times the determinant of what's left. Minus 1, 1, and 1. Now, this should be pretty easy to solve, and just to refresh on how to find the determinant of a 2x2 matrix, if we have a matrix A, B, C, D, the determinant is simply AD minus BC. So for the first, it would be 1 times minus 1 times 3 minus 1 times minus 2, minus 2. Next, it'd be 0 times 3, 0, minus 1 times minus 2. And the next would be 2 times 0 times 1, 0, minus 1 times minus 1. Now, we can simplify that out. It becomes, we can just write this as minus 3 plus 2, minus 2, positive 2, plus 2, and 1. Which equals minus 1, minus 4, plus 2. That is equal to negative 3. Now remember, it is the absolute value. So it would be the absolute value of negative 3, which would just be 3. Now you know how to find the volume of a parallelepiped with 3 vectors. One key idea behind solving the volume was utilizing cofactor expansion. This was a technique we used to solve the determinant of a 3x3 matrix. If you'd like an in-depth video outlining how to do this, leave a comment and subscribe. Thanks for watching.